Okay, in this video, we're going to be given a trig value. Like in this case, we've got cosine is equal to 0.83. Now, we don't know what the angle measure is. Okay, so we're going to find the angle measure, but we want to find that angle measure in degrees, minutes, seconds. Okay, so the question states what angle in the first quadrant. Okay, that's important. Now, in the very near future, we're going to talk about how cosine value of 0.83 can actually occur in two different places. One would be in the first quadrant, and another would be in the fourth quadrant. Okay, for now we're just dealing with angles in quadrant 1. Okay, so just be aware of that when we start covering that in the future. All right, one of the things when we're dealing with angles and trig functions, a lot of times we're going to use Greek letters. Okay, so in this case I'm going to use theta, okay, which is kind of an O-shaped letter here with a squiggly line right through the middle of it. It's pronounced theta. Okay, so I'm going to call the angle theta in this problem. All right, so remember, we've got an equation here. We know the cosine of theta is equal to 0.83. Okay, so our unknown, our variable here is theta. So when I'm solving for an angle, you got to remember I'm going to use the inverse trig function. In this case, inverse cosine of the ratio here, 0.83, is going to be equal to my angle measure. Okay, so we want to use a calculator, scientific calculator, evaluate that. We're going to get a decimal version of the answer. So in decimal form, theta is going to be approximately 33.901 degrees. Okay, now I need to use my conversion factors and convert this decimal form to degrees, minutes, seconds, or DMS. Okay, so remember, we've got 33 degrees. Okay, that's not going to change, but we need to convert 0.901 to minutes and seconds. So we're going to take this value right after the decimal. We've got 0.901, and we're going to multiply it by the conversion factor, 60 minutes per 1 degree. Okay, so that's going to give me a little over 54 minutes, so 54.06 minutes. And I'm going to take this amount after the decimal here and convert that to seconds. Okay, so seconds would be 0.06. We're going to use the conversion factor, 60 seconds per 1 minute. Okay, that makes the minutes cancel out, and that's going to give me 3.6 seconds. Okay, so there's only one angle in quadrant 1 that has a cosine value of 0.83, and it's approximately 33 degrees, 54 minutes, 3.6 seconds. Okay, now pause the video here. Try to answer this question. What angle in the first quadrant has a sine of 0.4? Okay, pause the video, give it a try, and then come back and check your work. Okay, for this problem, I'm going to use beta. Okay, so beta looks like your normal B in the English language, but with a little tail here on the left side. It's pronounced beta. Okay, now sine, we're dealing with first quadrant. Sine could also be 0.4 in the second quadrant. And again, we'll talk about that in the very near future. But for now, we're going to deal with only the first quadrant. So let's write our equation. So the sine of beta is equal to 0.4. I'm solving for the unknown here, which is beta in this case. So I've got to use an inverse trig function to find that angle measure. Okay, so in decimal form, my angle is going to be approximately 23.578 degrees. Okay, so now we want to go through the conversion process. We've got 23 degrees for sure. We're going to take the 0.578. We're going to use our conversion factor and multiply that by 60 minutes over 1 degree. So that's going to give me 34.68 minutes. So I know I've got 23 degrees, 34 minutes. But now I want to do 0.68, make that seconds. Multiply by 60 seconds per 1 minute. So my seconds are going to be 40.8. So the angle measure in degrees, minutes, seconds form that has a sine of 0.4 is going to be 23 degrees, 34 minutes, and 40.8 seconds.